Welcome to part 2 of section 2.4. To continue on with regards to that the slope-intercept form that we were just doing, we have graphing that slope and y-intercept in that y is equal to mx plus b format. The procedure would be to plot the y-intercept as 0, b. We need a second point starting at the y-intercept and using m. So in the example I have here, y is equal to 1/2 times x minus 3. The y-intercept will be the point 0, 3. So we could put that here on our graph. Now, based on that, we have the slope here of 1/2. So we could go up 1 and to the right 2. So this point right here is going to be 2, 4. So our line will look something straighter than this. Based on that slope-intercept form. If the slope is 0, equation of the line is just y is equal to b as a constant function. If the slope is undefined, the equation of the line is x is equal to a, which is not a linear function. So if we want to convert from standard form to slope-intercept form, I have here 2x plus 3y is equal to 6. We would first subtract by 2x from both sides. Would have 3y is equal to negative 2x plus 6, and then divide by 3. We would get y is equal to negative 2/3 x plus 2, based on this particular equation. So converting from standard form to slope-intercept form, I also have here 2x minus 5y is equal to 20. We are going to subtract 2x from both sides. This would leave us with negative 5y is equal to negative 2x plus 20, and then divide by negative 5 from both sides. And we would be left with y is equal to 2/5 times x minus 4. To convert from point slope form to the standard form, we have y is equal to 1/2 times x plus 3. So in order for us to do this, we could subtract the 1/2 x and get negative 1/2 x plus y is equal to 3. And now typically we want the coefficient in front of x to be, well, not negative, and to be a whole number. Or I should say an integer specific. Well, whole number would be better actually. So we're going to multiply everything here by negative 2 to get rid of that fraction and the negative at the same time. We would be left with x minus 2y is equal to negative 6. The linear function f of x is equal to 45.9 times x plus 59.3 models the number of smartphones sold in some country, f of x, in millions, x years after 2006. We want the slope of this model and to describe what this means in terms of the rate of change of the dependent variable per unit change in the independent variable. Our slope was 45.9. So in this case, that means that the number of smartphones sold in some country, in this case, that value of f of x, so the number of smartphones sold in some country increases, since this is positive, by 45.9, the unit is millions, for each year after 2006. To describe that slope. And then finally, we have this one. When a person receives a drug injected into a muscle, the concentration of this drug in the body, measured in milligrams per 100 milliliters, is a function of the time elapsed after the injection, measured in hours. The graph of the function is shown to our right, with x as the hours after the injection, and f of x as the drug's concentration at time x. We want the average rate of change in the drug's concentration between 3 and 7 hours, which thankfully we have those points physically on here. We just need to find the slope. So this would be 0.02. This would be the second point, and this would be the first. Minus 0.05 divided by 7 minus 3. So negative 0.03 divided by 4. So to get our slope, pop that into a calculator to receive your answer, which would be negative 0.0075, which is the average rate of change in the drug's concentration between 3 and 7 hours. Let me know if you have any questions or concerns. Thank you.